So in this problem, we need to determine the value of the given trigonometric expression. So let us begin. Now, if we observe each of the terms, we see that we have product of a sine and a cosine function. Now that means here we can apply the transformation formula, which is if we have, let's say, 2 times sine of angle A times cosine of angle B, so that becomes equals to the sum of two sine function. So we'll get sine of A plus B plus sine of angle A minus B. Now, if we observe a problem, we'll see that here we have the factor 2 missing. So that's not a big issue. All we have to do is multiply and divide by 2. So that means now we will get half times 2 times sine of B minus C times cosine of angle A minus D. So this is going to be the first term. Then the second term will be 2 times sine of angle C minus A times cosine of angle B minus D. Then the third term will be 2 times sine of angle A minus B times cosine of angle C minus D. Right. Now we can apply the transformation formula. So we're going to get half times. So we have 2 times sine B minus C. So we're going to consider B minus C to be equivalent to A and A minus D to be equivalent to B. Then we should get sine of B minus C. So we have B minus C plus A minus D. Fine. Then this will be added to sine of A minus B. So we'll have B minus C minus of A minus D. So we'll get negative A plus D. Fine. Then we go to the next one. We have sine of C minus A plus B minus D. Then this will be added to sine of C minus A minus B plus D. Fine. Then we have sine of angle A minus B plus C minus D added to sine of angle A minus B minus of C plus D. Right. So now we have successfully applied the transformation formula. Next, what we'll do, we'll try to work with the second, fourth, and the sixth term. So let's do that. We're going to let the first, third, and the fifth term remain as it is. What we will do here is, so let's first note down the first term. So we have half multiplied to sine of B minus C plus A minus D. So here what we'll do, we'll take sine, but we're going to take negative as the common factor. So we have negative of, so this time we're going to get A plus C minus B minus D. So we'll keep the third term as it is. So we have sine of C minus A plus B minus D. Then coming to the fourth term, here also we're going to take negative as the common factor. So we get negative times, we'll take A plus B minus C minus D. Fine. Then we keep the fifth term as it is. So we have sine of A minus B plus C minus D. And coming to the last term, we're going to take negative as the common factor. So we have sine of negative times B plus C minus A minus D. Fine. So that's now, so we know that sine of negative theta, so this is going to be minus sine theta because sine is an odd function. And that means we can now get, so we'll have half times sine of angle B minus C plus A minus D. So here the second term will now become negative of sine A plus C minus B minus D. The third term will be as it is. So we have sine of C minus A plus B minus D. Then we come to the fourth term. So this will become negative of sine of A plus B minus C minus D. Then the fifth term remains as it is. We have sine of A minus B plus C minus D. And then finally we have negative of sine of B plus C minus A minus D. Now let's see one thing. So here we have the first term sine of B minus C plus A minus D. So this is exactly the additive inverse of the fourth term. So the first term and the fourth term cancels out. Then we'll see that we have the second term and the fifth term cancelling out, and then we'll have the third term and the sixth term cancelling out. So this is going to leave us with a value half times 0 or simply 0. So that means the value of the given trigonometric expression, so this is going to be equals to 0.